Okay, so welcome to CALQ 1, just differentiation. Now we are going to look at limits. Two questions. Evaluate the limit. A, the limit of x squared minus 4 over x minus 2 as x approaches 0, and the limit of root of x plus 2, like everything is under the root, minus root of 2 over x as x approaches 0. So let's start with the first one. So the first one, we have the limit of x squared minus 4 over x minus 2 as x approaches 2. You know that if we replace direct here, we are going to get 2 squared over 2 minus 2, which will give us 0 over 0, which is indeterminate form. We can't find 0 over 0. But we can manipulate this. Come closer. Check that on top. All right, so let me just rewrite it. So we get this squared over 4. You could, on top, we can actually factorize using the difference of two squares. So we get x minus 2 and x plus 2 over x minus 2. Let me write it. Let me write properly like a mathematician. So get that. You get x plus 2 and x minus 2 over x minus 2. Gone. We have the limit x approaches 2 for x plus 2. Now we can substitute and get 2 plus 2, which will give us what? 4. We can now conclude and say the limit of x squared minus 4 over x minus 2 as x approaches what? 2 is equal to 4. Easy peasy, right? All right, let's branch into another one. B is the limit as x is approaching 0 for this function x plus 2 minus root of 2 over x. Let's do the substitution direct. If we substitute directly, we are going to get root of 2 minus root of 2 over 0, which will give us what? 0 over 0. First replace. This is an indeterminate form. So we find means and ways of doing this. So the easiest way we can do this is we can rationalize the numerator. All right, we can what? Rationalize the numerator. So we write like this. So this is x plus 2 minus that over x. So we can actually rationalize by multiplying the numerator both sides. All right, we rationalize the numerator. So this will give us the limit as x is approaching 0. So we get this x plus 2. Let me just do this. Let me open the brackets. And minus root of 2. I'm going to multiply by the same, but it will be the conjugate. I think by now, if you know, so here there will be a plus now. Both sides up and down. So we have got x here. Then we multiply it by x plus 2 plus root of 2. This is what we mean by rationalizing the numerator. Now that we've done that, all right, so we made the limit. Of course, x is always approaching what? 0 there. So if I multiply this, all right, it means I'm just squaring the parts themselves. So I'm just squaring this minus, I'm also just squaring this. Check that. This is just the difference of two squares. If you've got a and that, how do we write? We say a plus b, a minus b, similar to this. So just transform this into this difference of two squares over. Or we can maintain our part here. There's no problem. Okay. All right. Next, limit as x approaches what? 0. So now let's square this part. Squaring this part, I'll just get x plus 2 by the laws of side sign. Even here, I'll just get what? 2 over x plus 2 plus that. I'll get the limit as x is approaching 0. Now here, this will give us 0. So we're going to get x over x. Open brackets there. So we have x, open brackets, then we have x plus 2 plus root 2, like that. So x and x gone. So we have the limit as x is approaching what? 0. So I end up having like 1 over root of x plus 2 over root of that. Well, we can now substitute direct. It's easy, right? It's easy. All right. We can just substitute direct. We are going to get the limit as, we can, since we are now substituting, don't write the limit there, just substitute direct, which will give us 1 over. So if I put 0 here, this will just become root of 2 plus root of 2. Root of 2 plus root of 2, we get 1 over 2 root of 2. We can conclude now to say, therefore, the limit as x approaches 0 for x plus 2 minus that over x is just equal to 1 over 2 root of 2. And you've shown that. And you are welcome. You are welcome.